In order to further test and understand Newton's second law, I observed the motion of a pillow as it fell from rest. By having the object fall from rest, I am able to observe the effect of force on velocity and position. Here is a brief look at the physics models relevant to the system. Two forms of Newton's second law predict the final velocity and final position, giving the initial conditions of net force, mass of system, and change in time. Note that since the F net does not equal 0, the final velocity will be changing. Iteration with a small delta t is preferable to ensure accurate results. The key components of F net that I will be examining are the weight force caused by the Earth's gravitational field and the drag force caused by the air in the direction opposite of gravity. In order to obtain my observational data, I analyze my video on tracker. I set my axes so that when my object falls, it will go in the negative y direction. The data I got shows that the velocity increased and the pillow falls faster as time goes on. Then, when creating my first computational model, I plugged in all the initial conditions and created a code mimicking Newton's second law formulas. Initially, the only force I took into account was the weight force. However, the program showed that the object moving much more quickly than in reality. In order to correct this, I modified the code to include drag force and determined a B coefficient through trial and error. My second code created a more accurate model of the pillow falling. Here is a graph comparing position to time for the tracker data, VPython data accounting for gravity, and the VPython data accounting for gravity and drag force. Here you can see how much the gravity alone overpredicts, while the other two are more closely related. Some error may have occurred when I estimated the mass of the pillow, since I did not have a very precise scale. Also, the pillow was more of a blur as it was falling, so if I had used a better quality camera, I may have had more precise center of mass points. Terminal velocity is the velocity when the net force is equal to 0. This would cause the velocity to go on unchanging. Notice how in all models the slope is curved. This shows a changing velocity. Therefore, no model displays terminal velocity. Now, what if the object were thrown down instead of just falling from rest? The initial velocity would be greater than 0 due to the force of the throw and would continue gaining speed. I created another computational model where the initial velocity was already moving in the negative y direction, and I found that the velocity would have increased more after 3/4 of a second in this case.